Okay, so these are the solutions to the quiz from Friday. Some of you had some troubles and some of you did very well. So you can watch this at your leisure. Number one is the first one. These were all straight problems from the homework. So this is section 4.1. Number one strictly is a distribution. So this times each one of these members here. So this is 5x squared. Positive 5 times a negative x is negative 5x. Positive 5 times a negative 2 is negative 10. Now, this is a negative 3 out in front here. So negative 3 times a positive 3x squared is negative 9x squared. Negative 3 times a negative 2x is a positive 6x. And negative 3 times a negative 6 is a positive 18. Now, I like to use this little check as I do these and collect the like terms. So here is the second degree. So combine negative 9x squared and 5x and we get negative 4x squared, and we can check that off. Next is the x to the 1 term, so a negative 5x plus a positive 6x is plus 1x, but we don't write that. So plus x, that is done. And a negative 10 plus a positive 18 is plus 18. And those are done. And this is the simple, I'm sorry, that's not 18. My bad. A negative 10 plus 18 is positive 8. So this is negative 4x squared plus x plus 8. I'm sorry about that. Number two is checking the distribution. What happens to a monomial inside here when you raise the outside to a power. So everything gets raised to the second power here. Everything does. So a couple of ways to think of this. This is 4 to the 1 times x to the 1 times y to the 1 all squared. And this is equal to 4 to the 1 times 2, which is 2, x to the 1 times 2, which is 2, and y to the 1 times 2, which is 2, which is 16 x squared y squared. Now, this is the trickier one because there is a coefficient in front here that's understood. That's negative 1. So listen, negative 1 to the third is equal to negative 1 times negative 1 times negative 1. That's a positive 1. That's a negative 1. So that is negative 1. So back over here, this is parentheses negative. X to the third is x to the 1. And this is y to the second, all raised to the third. So this becomes negative x to the third, y to the sixth. And down here then we still have some work to do. So this is times negative, x to the third, y to the sixth. Now, we add the exponents. So we're left with 16 times a negative 1 here. So that becomes negative 16. X to the second times x to the third, add exponents. This is x to the fifth. Y to the second times y to the sixth is y to the 2 plus 6, which is y to the 8th. This simplifies to negative 16 x to the fifth, y to the 8th. Here is number 3, number 4, and number 5. couple of ways to do number 3. There is one way where we can basically we have 3 components here all times each other. One simple way is to recognize that this in the middle under the green here, g plus 6 times g minus 6, the middle terms are going to drop out, and we're going to be left with g squared minus 36, and then we can simply distribute from there, and we would end up with g times g squared is g to the third minus 36g, which is in fact the answer. Another way to do this is by saying, let me grab a different color here, is by saying I'm going to multiply this first one by g. Let me get yet a different color here. I'm going to multiply this first one by g. Okay, so I'd get g times g, which is g squared, g times positive 6, which is positive 6g, and I still, because it's multiplication, still have g minus 6 over here. Now I distribute once again, and I get g squared times g is g to the third. G squared times a negative 6 is minus 6g squared. 6g times g is plus 6g squared. 6g times negative 6 is minus 36g. Now if you look, these two terms cancel, and we're left with g to the third minus 36g, which is the answer that matches this. Okay, let's go to number 4. Is g is the greatest common factor and LCM. So to do these, we want to factor these. I want to emphasize that you should make a ladder here and start with 2, since this is even and this is even. This is 2 times 27. 2 is a prime. This is 3 times 9, and that is 3 times 3. So that means that our factoring is 2 to the first times 3 to the 1, 2, 3. So that's 3 to the third. Sorry, that's a little messed up there. This is 3 to the third. Let's do the same thing with 90. We can easily do that this is 2 times 45. And 45 is either 3 times 15 or 5 times 9. It works out whichever way you want to do it. And this is 3 times 5. So this becomes 2 to the first times 3 to the second times 5 to the 1. Now, we have this one, this factored out. The GCF, you take what is common to both and the lowest exponent. So this becomes 2 is common to both, to the first. 3 is common to both, and we use the lowest exponent, which is the second. So that makes this 2 to the 1 times 9, which is 18, which is the greatest common factor. Over here, the least common multiple, we take every prime factor between these two to the highest. So every common factor would be 2 and 3 and 5. Take the highest exponent. So 2, the highest exponent is 1. 3, the highest exponent is 3. Highest exponent of 5 is 1. 2 times 9 times 5 is 270. Here's number 5 in the quiz. as we get more complex here, what you need to start to do is by inspection, which is something I've said to you in class. By inspection, which means look it over. See what you might be able to do. This might be, if you look at the first exponent here, this might be a cube term or a perfect cube term. The problem is that if you look at the last term or any of these other components of this polynomial, this is the only cube term over here. So that's, to think that this is a perfect cube somehow that you have learned is not going to work. And the reason is I don't see any d cubes in here, or 45 is not a perfect cube, etc. The second, in the first option in all of these, in simplifying, is take out a common, see if you can factor out a common factor. That's always the first place to start here. The other way, and we're not going to do it in this, is regroup. So regroup or reorganizing, taking out a common factor are the first two things to look for here. So look, is there a common factor numerically here? Yes, there is. There's a 5 here. That's a common factor to all of these terms as the coefficient. And c is a common factor to all of them. Yep, it is. And it's only c to the 1. So if I factor this out, if I factor out a 5c, I am left with c squared here. Plus, well, 5 goes into 36, c goes into c once, and we're left with d, and 5 goes into 45 9 times, and we're left with d squared. Now again, if you look at this, one of the other things you want to start looking at here, are our unique forms here, a plus b squared, a minus b squared, and of course difference of two squares, a minus b times a plus b. Why do I say that? Because that is what this form is. We have a squared term in the front, a squared term in the back, and this is positive, so that means this is all positive factors. So the square root of c is c, which means we have it both here and here. The square root of 9d squared is positive 3d and positive 3d. And to simplify even further, this then becomes, whoops, I have 5c here. This becomes 5c times c plus 3d all quantity squared. Okay, looking forward to the week.